let's look at the chain rule. Right, let's look at what a chain rule is. Right, hello everyone, welcome back to another Matthew Day channel. So in our previous video we looked at the quotient rule, right, and the product rule, right, when we how to derive a function that how to derive a function, or how to derive two functions that multiply each other or two functions that divide each other. But in this case, we're going to look at how to derive a function that is in a square root, a cube root, that is raised to the power negative 7, negative infinity, negative infinity, and positive infinity. Right. So what I mean is, if we are given a function hx, which is equal to some function fx raised to the power n, where n is an element of real numbers, right? N is an element of real numbers. The question is, how can we differentiate such function, right? Okay, so let's look at an example with respect to that, right? Let's say I have fx is equal to x minus 2 squared, right? How will you go about differentiating this? Well, you will tell me, okay, we could expand the bracket, right? It could be easy. I could expand the bracket. It could be x minus 2 and then x minus 2, right? And then I could use the FOIL method. Right? I have x squared minus 2x plus 2x minus positive 4, right? And hence I have x, actually is positive, negative here, it's negative, and then I have negative x squared minus 4x plus 4, right? And then thereafter I will go ahead and differentiate this function here, right? It will be easy. I'll have 2x minus 4, right? Using the power rule, right? I can differentiate this. But what if I told you there was another formula that we could use to differentiate this? Remember, here we got, what did we get? We got 2x minus 4. But if I told you there was another method that we could use to differentiate this function here? Well, let's let this function here equal to hx, right? So therefore I have fx equal to h raised to the power 2, right? So in this case I have a function inside, and I also have my value of n, right? Okay, so now how would I go about differentiating this? Well, the formula, which also comes from the first root principle, it states that if I want to differentiate this function here, then f prime of x will be n times the function inside multiplied by the derivative of the function that's inside, right? Hope that makes sense, right? So it's basically n and then n minus 1. So it's n, you bring the n forward, and then you subtract by 1, and then you multiply whatever you get with the derivative of the function, right? Let me just explain that, or rather let me differentiate this function here using the exact formula. Remember, this is our derivative here. We should get the same answer there. Well, the formula states that hx is equal to n fx and then n minus 1 and then times f prime x, right? This is the formula of this function here, right? There you go. Just zoom this out. There you go. So if we can derive this one here, we bring the 2 forward. Therefore it will be 2 times whatever it's inside we leave as is. Therefore it will be x minus 2. Then there we subtract 1, and then times the derivative of what's inside there, which the derivative here using the power rule will be 1, right? If you derive what's inside here, you'll get 1. And then now I can just solve. Here it will be 2. Here I have x minus 2, and then 2 minus 1, that's 1. And if you solve further, you have 2x minus that times that times that is 4. And look at that, we get the same answer, right? So we get the same answer, right? So let's look at some more examples. So yeah, just write this formula down here. It's very important. Let's look at another example. Let's say I have fx is equal to the square root of x squared minus or positive 4, right? Go ahead and try this on your own, right? So this one here we can simplify it, or rather not simplify it, but we can remove that square root there and put it there as an exponent. Therefore it will be a half there on top, right? Now I can derive. Therefore I have f prime x is equal to, take the half in front, to be a half times whatever is inside we leave as is, x squared plus 4, and then a half you subtract that by 1, subtract this one by 1, and then times what inside here, right? When I times what the derivative of what's inside there, which is 2x, right? And if I can solve this one here, I know I have a half, and then a half minus 1 will give me negative 1. Therefore we will have here times x squared plus 4 negative a half, and then times 2x, right? And then here the 2 and the 2 will cross cancel, and hence you have x on top divided by, remember we do not want the negative exponents, therefore and I bring that down, which is x squared plus 4, right? So that is how we derive using the chain rule, right? Let's look at another example so that we can get the concept. Let's say we have gt which is equal to t square root of t squared plus 1. So here you can see that we do have two functions that multiply each other. So what does that mean? It means that you're going to use both the product rule as well as the chain rule, right? So note this down. You won't always get just because I'm teaching you the chain rule doesn't mean that you will get the chain rule throughout, right? It will be a mix. You will have chain rule mixed with product mixed with the quotient rule in one place, right? Just like we did the other one here, you can see that this one here is not only the chain rule, but it is the chain rule that is mixed with the power rule, right? It's mixed with the power rule. They all come from the first principle. I mean, you can't do this using the first principle, but it will take you a long time, right? So you make some mistake as you go on, right? So if we can use the product rule here, we can differentiate this one here. So let's first use the product rule. The product rule says we differentiate the first one here, or the second one, doesn't matter, then you multiply it with the second one, and then after that we differentiate this one, you multiply it with that one, right? So let's do that. So it will be gt that is equal to the derivative of t, right? And the derivative of t times what? Times that function here, plus 1, and then plus t times the derivative of that function here, t squared plus 1. Okay, now let's derive, or let's find the derivative here. So g prime t is equal to the derivative of t is 1, and therefore 1 times t square root of t squared plus 1 is square root of t squared plus 1, and then plus t times the derivative of that. Well, this one you can change to t squared plus 1 raised to the power a half, right? And then you can differentiate, right? Remember, you bring that one in front, and therefore you'll have a half, and then times whatever it's inside there will be t squared plus 1, and then raised to the power a half minus 1. Okay, right, 2 plus 2, that's 1, and then times the derivative of what's inside is 2t, right? Let's simplify further. You'll have t squared plus 1, and then plus here I notice that these two will cross cancel, these two here will cross cancel, and then t times t, that's t squared, and then this one here will give me a negative a half. Therefore, if you bring it down, you will have something that looks like that, right? So in that case, that means that my g prime t is equal to g prime t is equal to t squared, square root t squared plus 1 plus t squared all divided by t squared plus 1. I mean, you could simplify it if you want. Simplify further. Let's see. Therefore, you can add these two. You will have t squared plus 1 plus what? Plus t squared all divided by the square root of t squared plus 1, and hence you get 2t squared plus 1 all divided by t squared plus 1, right? I mean, you could have left it like that. That is totally fine as well, right? That is totally fine. Or you can just simplify it and you get that answer, right? I hope that makes sense. Let's look at the last one, the last example here. So the last example, let's say find dy dx if you have y is equal to the square root of t, as well as x is equal to 4x squared minus 4x plus 1. The question says find dy dx, right? So in this case, let's first find dy, right? Dy dt. Let's first find dy dt, right? So here we have t. It's fine, you can say t, doesn't matter. I mean, you can take this whole thing here, which is t, and substitute it there, and then you can derive thereafter, right? But again, you can do this form, you can do this method here by saying, well, this one here is the same as t a half, and you know this one is a chain rule. Therefore, to derive that, I will bring the half forward, and then t a half minus 1, and then times the derivative of what's inside, which is t, which is 1, and therefore you have a half and then square root of t, right? So that there is my dy dt. Okay, now let's find dt dx. Well, here this is simple. You're gonna use the power rule, minus 4, right? And here they wanted dy dx, right? So meaning I have to flip this one around here. I have to flip this one around. So if I have dx dt, that will mean that I also have to flip this one around, which is 8x, or rather 1 over 8x minus 4. Then I can multiply dy dt with dx. No, actually we already have dt dx, so there's no need for me to flip, so I can just multiply the two, which is dt dx, right? So I took that one and multiplied with that one, and dy dt is this part here, which is 1 over 2 square root of t multiplied by 8x minus 4, right? And then here we notice that these two here will cross cancel, and then I will have my dy dx to be equal to 8x minus 4 all divided by 2 t, right? So that is what our answer is. But here we are differentiating y with respect to x, right? But in our formula we have, rather in our derivative we have t, so meaning I have to replace the t with this part here, so meaning I have 8x minus 4 all divided by 2 and then square root. Remember t is equal to that part there. If we have 4x squared minus 4x plus 1, right? So that is what we mean, or rather that is our derivative, right? You can see how easy this thing is compared to using the principle, or rather the first principle, right? You'll have multiple steps and you'll make multiple mistakes as well, right? So I hope that you understand this one and try to do more examples, right? So let's look at one more example. So let's say we have y is equal to x plus 3 raised to the power 4, right? Find dy dx, right? So here again, simple. We're gonna bring the 4 up front. Therefore dy dx is equal to 4 times, we leave what's inside as is, x minus, or rather plus 3 raised to the power 4 minus 1, and then times by the derivative of what's inside. So the derivative of x, or rather the derivative of this one here, you're going to use the power rule, which is 1, and then just simplify this one further. You have x plus 3 raised to the power 3. So there, that is my dy dx, right? That is my dy dx. I hope that makes sense, and yeah, I'll catch you on another one. Please try to do more examples and do more examples until you get it, and try to compute all these rules together. Use the product rule, the quotient rule, and the chain rule together, and see what you can do, right? So let me just give you an example of that. Let's say you have y is equal to let's say I have x squared minus let's say plus 1 times x plus 3 all divided by x minus 1, and then times rather raised to the power 2, right? Try to find dy dx. In that case, find dy dx, and if you couldn't find one, comment down below. I'll do like an example, or rather I'll do this question here on another video. But if you find value, please comment down below, like the video and subscribe. So I'll catch you on another one. Cool.